Hey guys, we're going to do 10-2 lesson check. So let's do it. All right, question number 1 says, given that the DC, so DC is the tangent to this circle at C. So what that means is, based on our theorem we said today, that means that it makes a 90 degree with the radius, okay? So given this information, what else must be true? So they're saying, does angle DCN, so that's our 90 degree angle, right? Is that less than the angle BAN? So let's find out what that angle is in order to compare. So first, we look at this triangle and we see that, okay, one of the angles, all these angles have to add up to 180. So you have 180, take away the 90, so that's 90, and take away the 51, and we get 39. Okay, so this is 39 degrees, and it's a right triangle, right? Then we notice that this is a vertical angle. So if this angle is 51, this angle also has to be 51. And we can compare it to this triangle. And we can say, okay, well, triangle BAN also has to add up to 180. So you have 180 take away 39. So you get, what is that? 141. And then take away 51. So you get 90. So you're like, oh, okay, yeah, those are congruent triangles, and that is 90. So is this less than? Is 90 less than 90? No, it's equal. So that should be a congruent sign. Now the next one says, is BAN tangent at A? Okay, so they're asking, is this line tangent? Well, this is actually the converse of the theorem. Our converse theorem said if this is a right angle, then this has to be tangent. So we're going to say yes, and that should match our answer. A no and a yes. All right, question number 2. What is the parameter? So these are tangents, and we said that if two lines are tangent from the same point, so point Z creates two tangent lines, then if this is 6, this would also be 6. All right, so we kind of look at this hat over here. If this was 5, that would be 5. And this last one, this was 7 here, so this would be 7. Now we can find the perimeter of this triangle. So we can add up all 3 sides. So the first side, this one, yeah, YZ is 7 plus 6. And the second side, XC is 5 plus 6. And the last side, YX is 7 plus 5. So we have 13 plus 11 plus 12. So let's add all those up in a calculator. We get 3, 4, 5, 6, 36. And that matches one of our choices. Nice work. All right, next question. It says if PQ is tangent, so if PQ is tangent, that means this is a right angle. And if PS is tangent, so that means that's a right angle, what would be the perimeter of the quadrilateral PQRS? So PQRS, this quadrilateral. So the perimeter would be, I have to add up the 4 sides, just like we added up the 3 sides of our triangle. Okay, so this radius is 5, and all radii are equal, so this would also be 5. So 2 of the sides of our quadrilateral are going to be 5 and 5. And then these have to be equal to each other. So we just have to figure out what these are. So if we focus on this, we know this is a right triangle, right? And we know this is also 5 because it's a radius, right? So if I look just at this orange triangle, I have 9, 4 plus the 5, right? And the 5. And I can solve for this, x, using Pythagorean theorem. So just kind of looking at, it is a right triangle, so we can solve, one of the legs is 5, another leg we don't know, so we'll call it x. And then The hypotenuse is 9. Doing a little algebra here. What do we get? Minus 2 is 5. Okay, so we'll take the square root of both sides. So we get the square root of 56. So this is the square root of 56, and this is the square root of 56. But that doesn't appear to, oh, I like this 10, right? Because 5 plus 5 is 10. That's looking good. So we get 5 plus 5 plus the square root of 56 plus the square root of 56. But it looks like we may have to do some simplifying. So it looks like maybe there is something even inside there. Yep, and 56 is even. So let's dive a little deeper here. If I divide 56 by 2, we get, what do we get here? 56 divided by 2. I don't have my calculator around, so I'm just gonna, yeah, okay. So I get 28, and then there's another 2 in there. So I'm just going to divide it again. 28 divided by 2 is 14. Okay, oh, we like that, 14. So the 56, or the square root of 56, rather, is the same as saying the square root of 4 times the square root of 14. And the square root of 4 is actually 2. So we can say this side is 2 times the square root of 14, and this side is 2 times the square root of 14. And we can rethink the perimeter as 2 times the square root of 14 plus 2 times the square root of 14. So I would get 10. These would combine to get 10, and I have 2 square roots of 14, so that'd be a total of 4 square roots of 14. And there you have it. Final answer. All right, next question. Given AB is a tangent, so if I'm told that's a tangent, then I know that's a right angle. Find the circumference. Okay, so we have a right triangle, right? And so this should work. So this side is my radius, right? That's my radius. This other leg is 2r minus 1, and I'm going to square it. That's because that's my B. And my hypotenuse is actually this combined. So I have to add that together. R plus 1 plus another R. So that would be 2R plus 1. So the last leg, or C, is 2R plus 1. Okay, so doing a little algebra here, we get 2R minus 1 times 2R minus 1. And this side, we get 2r plus 1 times 2r plus 1. All right, so this is called foiling. I'm going to multiply the first 2 terms. And this one and this one, and then this one and that one, right? Minus 2r. Then I'm going to multiply these 2 terms. Minus 2r plus 1. Okay, doing the same thing here. Multiply these 2 terms, and these 2. And then these 2. And those 2. Okay, so let's clean this up. It looks like I have a 4r squared on both sides. So that, if I subtract 4r on both sides, it just goes away. And it looks like I have a 1 on both sides. So if I subtract 1 on both sides, that'll go away. Okay, so then let's clean this up. So I have an r squared left over, a minus 2r minus, so that would be a total of subtracting 4r. And those cancel, right? Those would go away. And then I have 2r plus 2r, so that's 4r, and that went away. Okay, so I'm getting rid of a lot of stuff here. It's getting a little simpler. Let's subtract 4r on both sides. So I get r squared minus 8r equals 0. Okay, almost done. I can factor out an r, and if I set this equal to 0, so I get 2 solutions. Either r is equal to 0, or the first expression, or the second expression. So if I add 8 on both sides, I get 8. Okay, cool. So now that I know the radius is 8, they want to know the circumference. So our circumference is 2 pi r. So 2 times pi, and our radius is 8, I get 16 pi. There it is. Nice work. Wow, right? We're getting toward the end of the book, so we're getting more and more into algebra as we get closer and closer to algebra 2. Okay, this last one's kind of cool. It says, using construction, list the steps to construct a circle P through point, a tangent to circle P through point T. Order the steps first at the top, last at the bottom. Okay. So here's what's important here. You're going to be learning a lot of the steps. Right now, notice I only have P and T, so I can only really do anything with P and T. This is talking at point C. I don't even have that yet. Here, it's saying label point C. So that tells me 3 has to go before step 2 because I don't even have point C yet. Here, oh yeah, I'm noticing this says label point B. So this is going to help me use logic and reasoning to kind of work my way through this. Okay, so I'm going to try to use number 1 as my first step. So it says use a straight edge to draw PT. So just draw a line. Okay, that looks good. Label point A. Okay, so that's how A got there. So that's going to have to be either the first or the second step. Okay. Now we have A. So I'm looking for one that talks about A. And I notice the only one that talks about A is this one, number 4. So I'm going to say, I'm going to do 1 first, then 4. So let's try that out. Use a compass to make a circle at center P passing through T. Construct a perpendicular to TP at A. Okay, so use a compass to make a circle, center passing through T. So it's like, it's one of these concentric circles, similar to what we worked on, I think, example 5. All right, and then it says construct a perpendicular to TP at A. So constructing a perpendicular line of TP at A. Label point B where that perpendicular intersects. So we're going to call this B as in boy. Okay. Now that I have point B, I am going to use, I'm going to go to I think number 3 would be the next step. It says use a straight edge to construct BP. Okay, so use straight edge to construct BP. Did that. Label point C where BP intersects the inner circle. So we're going to call that C. Okay. Now, the only one I haven't used is 2. So let's take a look at it. It says use a straight edge to construct TC. All right, so last step, use a straight edge to construct TC. And look at what we've done. We did it. We constructed a tangent line to that inner circle from point T. Cool, right? So this was what they asked us to do. Construct a tangent line on the inner circle from there, and that's exactly what we did. Nice work, guys. It looks like I followed these steps. Take care.